Okay, so let's just start with a review of what we did yesterday, and we'll go from there, okay? So today shouldn't be too painful at all. It's just going to be button pushing on the calculator. So it says here the sine graph has a maximum value of 20 and a minimum value of 10, and it passes through the point 12, 15. Okay, so if this was a diploma exam question, they would have that same explanation given, but they would also indicate the points on the graph as well. Okay, so it says a maximum of 20, a minimum of 10, and you have a point at 12, 15. Okay, so the equation is y equals a sine bt plus d. Okay, in all of these questions that you're going to do, it is the b number that's going to drive you wild. It's the one that's the trickiest one. Okay. Okay, so let's just start with the eyeballing it here. Do you see that if you drew a line through 15, that you've got equal space above and below, right? So again, it should make sense. Now, if you didn't want to do that, your other option would be to say, okay, what is the total distance that I have to go from 10 to 20? Well, I have 10. If I divide that by 2, I get out 5. So if I come 5 down from 20 and 5 up from 10, notice I land at 15. So the amplitude calculation, as well as eyeballing the midline, those two answers should give you the same number, right? They should both work together. If they're working against each other, you've done something wrong. If you end up at the same spot with each one, then you know you're on the right track. So we know that our amplitude is 5, and we know that our midline went up to 15. So again, for me, if this is a question on your exam on Monday, that's worth 2 marks out of 3. So I just give you 1 mark for each letter that you find. Okay. Okay, so the B value is the tricky bit. Okay, B goes with period. So in order to find the B value, I have to use the formula 2 pi divided by period. Period, remember, is the length of one cycle. Okay, so this is why this question sucks. That picture that you were given in your workbook, can you see an entire cycle? No. So you have to extend this to figure this out. Now look, from here to here is 12. So then what do you know if it's going to be from here to here? 12. So you know the period has to be 24, right? Because it's for the total length of the cycle. So it's not hard. It's just that, because you know what? One of the answers in the list will be 12. The other answer will be the 24. So if you want to leave this as an exact answer, you would reduce the 2 over 24 to 1 over 12. Okay, so that's the exact answer. If you were to show it as a decimal, you would go 1 times pi. Whoops, that's not right. 1 times pi divided by 12. Or 1/12 times pi, doesn't matter. So 0.26. So the other way to write the answer would be 5 sine 0.26 t plus 15. So one's exact, the other is what we call approximate. Okay. So very typical diploma exam question is where they only give you half the period instead of the whole kit and caboodle. Will they ever give you only a quarter of it or an eighth of it? No, they always do half. half or full. Okay, so flip the page. Let's try it a harder one. Let's try number 9. So number 9. So just give me a second here to draw this out. Okay, so it goes like that. So you're just kind of drawing. So that's all it gave you. Okay. So let's just start with the tops and bottoms. So we've got y equals a sine bx. So this thing right here, that's what's called the phase shift. And what that's doing is it's just changing the starting point of sine. So sine's not starting right at 0, 0. It's just been moved. It doesn't matter to you at all. It doesn't affect anything that you're going to do in 30-2. We're just working through a couple questions in the workbook. Nope, we haven't handed it out yet. Okay, so let's start with what we do know. Let's just do D and A. So this thing goes up to 10 and down to -3. So this thing is -3. This thing's 10. So in terms of total height, this thing covers a distance of 13. Okay? So half of that is 6.5. So I'm going to come up 6.5 and I'm going to come down 6.5. So the amplitude is 6.5. Okay, so you can do this either way. You can go up 6.5 from -3, or you can go down from the 13, or sorry, down from the 10, 6.5. Either way, you'll land at 3.5. Are you okay? Is it 13? Oh, it didn't go up to 13. It went up to 9. Oh, okay. Hold on. Oh, let me just, oh, it's not going to let me. There we go. Okay, sorry. This goes up to 9. So 9, from 9 to -3 is 12. So that makes it a 6. So this is a 6. Thank you for catching that. So then we would go up 6 and down 6. So that lands you at 3. There we go. Thank you for seeing that. So the midline is at 3. Okay, so I went 6 down and 6 up. Okay? Okay, so do you see how, so remember what we said yesterday, that sine starts on the midline? That's why, see how it's not quite at 0? It's been shifted over. That's this number right here. It's just been shifted off of the y-axis just a little tiny bit. So same problem as before. I don't know how long this thing is, but I can figure it out. Okay. So from bottom to top, this is half the cycle. Okay. Because they haven't given you the total. See, like here, if I were to draw the rest of the curve in, see how I need to go from bottom to bottom, right? That's the full cycle. It doesn't matter what part of the wave you're doing. If you want to do the whole wave, so you go up, down, up, that's the sine wave. If you go bottom to bottom or top to top, you're just taking a different part of the wave, but the period stays the same. Now, the tricky bit here is figuring out the scale. So, right here, you've got the number pi, and then pi over 2 with 2 more. Okay, take out the pi. What number's in front of this pi right now? This is 1, right? This is 1/2. So each one of these is counting by a quarter, right? So this is a quarter, this is a half, this is 3/4, this is 1. So each jump counts for 1/4. So what I'm going to do is I'm going to count the squares. So this bottom right here, I'd have to go 1, 2, 3, 4, 5, 6, 7. Is that right? So to the peak, oh, no, it's 1 after that, 8. So the top occurs 8 quarters. Okay, it has 8 jumps from bottom to top, and each one of them is a fourth of the way. Well, 8 divided by 4 is 2. Then stick your pi back in. So just count squares to go from start to finish or the halfway point or whatever, and then just divide it by what you're counting by. So I counted 8 jumps, and each jump is a quarter of the way. So 8 divided by 4 is 2, and then you stick your pi back in. So the b value is 2 pi over period. My period is 2 pi. Well, what's 2 pi divided by 2 pi? 1. So b just equals 1. Now, for the life of me, I cannot remember if on your diploma the scale was like this. I'll come back to it. Or if the scale was like this. I can't remember because this is way easier, right? This is way easier than this guy. And I can't remember which one it was on the diploma, to be honest. Okay. But that's what we learned yesterday. So I always do the A and the D first, and I just do them together at the same time. And then I start messing around with this formula to find the B value. Okay? So we're going to move into the last lesson of Math 30. Okay? And this is just going to be a big old button push today. That's it. Okay? So I'm actually going to do this example, this handout first with you. 2, 3, 4. So we're just going to do a little bit opposite order to what the workbook is, just because I think it's a little easier. Okay, but I'll give you a quick second here to catch up. Okay, have you caught up? Okay, so I'm just going to go ahead to this guy. Okay, so it says in 2011, the Singapore Flyer was the largest Ferris wheel in the world. The table below gives the height of a rider from the ground at different times. So at time 0, he's 49 feet off the ground. Then he's 295 feet off the ground, then 541 feet off the ground, and then 295, then 49. Just think about this for a second here. You've got the time in minutes, and you've got the height in feet. So at time 0, he's 49 feet off the ground. And then look at the numbers. They go up, up, up to a peak, and then they start going down. Then they start going back up again, then they start going down. Think about a Ferris wheel, right? You're on this Ferris wheel. You go up, and then you come down. Then you go up, and then you come down. And then maybe the ride ends after 2 times around or whatever. That's a sinusoidal wave, right? It's a wave. You go up, you come down. You go up, you come down. So, well, you know what? Actually, almost all engineering examples come back to sinusoidal curves. So if even you look at sunrise, sunset times. So on the darkest day of the year is December 21st. The lightest day of the year is June 21st. So December 21st in Canada, we have 8 hours of daylight, 16 hours of darkness. On June 21st, we have 8 hours of darkness and 16 hours of daylight. So if you look at the sunrise time, it would be the exact opposite. So let's say if this is June 21st here. So June 21st, the sun rises at, let's say, 4:30 a.m. December 21st, the sun rises at 9 a.m. Next June 21st, 4:30 a.m. So the sunrise time goes up and down. You can also look at amount of hours. So on December 21st, you only get 8 hours of daylight. On June 21st, you get 16 hours of daylight. And then 8 hours, 16 hours, 8 hours. So that's going up and down. Somebody jumping on a trampoline. They go up, they go down, they go up, they go down. Tide heights. So when you look at the height of water, so tide is pulled by the moon. So typically within a 24-hour period, you have a high tide and a low tide twice. So it goes out, comes in, goes out, come in. So the depth of that water is deep, shallow, deep, shallow. And that one's super important for cruise ships. So cruise ships need to know when they can come into the harbor versus when they have to leave the harbor by. And it goes up and down and up and down in that pattern. Okay. So there's actually a lot of examples of kids who go into engineering. They actually do a deep dive into sinusoidal functions because most engineering and natural occurrences follow this, what we call a sinusoidal rhythm. If you look at your heart rate and your pulsing, so like that, that follows that. And when they set you up to like an EKG or they do an ultrasound, if let's say the two peaks are too far apart or the two peaks are too close, like that shows hypertension. Or it shows that maybe you got a blocked ventricle because the heart's pumping way, way, way faster than what it should because it's just trying to overcompensate. So this idea of like these functions, they happen all over the place. So like medical fields, same thing. So when you take pain meds, when you take a Tylenol, right? Your body, you get the best effect at this point, and then as time goes on, it wears off, so your pain increases. So you take another medication here, right? It starts this idea of it's metabolizing. And so metabolic rates based on a person's weight, age, sex, sinusoidal functions. It's actually pretty cool. So, okay, so we're going to do this. So you already have the notes for this in the polynomial section that I gave you, but it's the exact same notes. So we're going to do a list 1, list 2. We have to clear out all of our lists, and then we'll go from there. So I shrunk this down. Okay, so how do we clear lists? Second plus 4, enter. Okay? Okay, how do we enter our lists in? So stat number 1, list 1. So list 1 is always your X, list 2 is always your Y. If you're not sure what X should be, it's always whatever in the first column or the first row, depending on how they orient the table. So slow down here. Make sure you're entering it in correctly. 37, 46.25, 55.5, 64.75, and 74. Okay, and then go over to list 2. So we've got 49, 295, 541, 295, 49, 295, 541, 295, 49. And by the way, the reason why he gets on 49 feet off the ground is because you can't enter at ground level, right? Because when that wheel comes around, you're going to hit the ground, right? You always have to enter in, like you always go up steps or up a scaffold, and then the wheel often will dip beneath you, right, as you go around. So just make sure that you land on the same line and try to make sure that you haven't punched anything in wrong. Now, do not hit graph at this stage. At this stage, this is where you do your X min and X max, your Y min and your Y max. Okay, so don't enter anything in. Okay, at this stage, you're going to do your window setting next. So step 1, clear lists. Step 2, L1, L2. Step 3, x min, x max. So look at your x. So look at your x's here. They go from 0 to 74 minutes. Okay, so we want to go from 0 to maybe 100 minutes. Okay, a little bit beyond 74. Look at your y list. Your y list goes from 49 feet to 541 feet. So I would say from 0 to 700. Okay, so you use the table to create your window setting. Still don't hit graph. Do not hit graph yet. We're not there. The next step is to hit y equals. Clear out anything that you've got there. But more important than that, what else do you have to do? You have to turn on plot 1. Okay? Now, when you're not doing regression, so when you're just using y equals to graph the quadratic or the cubic, right? If you're just using a plain old y equals, this has to be unbolded. But when you're doing regression, this must be bolded. Okay? Now, hit graph at this point. Do you see that wave pattern? If you were to do an imaginary connect the dots, do you see it go up, go down, go up, go down? So in our polynomial section, right, in our polynomial section of this unit, we plotted the points and then we chose, did it create a line, did it create a quadratic, or did it create a cubic, a wiggle, right? With trig, they're going to tell you to do a sine reg. They're going to tell you to do a trigonometric regression. But if for some known reason they don't, then you're going to plot the points so you can see what pattern you're dealing with. So now, so we've got the list set. We've looked at our graph. We can clearly tell it's a wave. So now we're going to find the equation of that wave. So quit out, go to stat, go over to calc. Now hit your up arrow. Hit the up arrow and you will see letter C. Letter C is sin reg. Okay, the reason why you hit the up arrow is that this thing is on it's on a circular menu, just to prove to you. If I hit the down arrow, I'd have to hit it a whole bunch of times before I get to letter C. But you can go up or down, it's up to you. So hit enter for sin reg. Okay, go down till you get to calculate. And there's the formula. So it says for part B, determine the regression equation, round to the nearest hundredth. So how many decimal places is hundredth again? 2, right? So we've got right here. Okay, so the regression equation would be y equals, so A is 232.54 sin 0.16 x minus 1.14 plus, okay, is mine wrong? Okay. Okay, so I've punched something in wrong here. Let me just go back to number 1. 125, 49, 295, 295, 49. Thank you. Good eye. Okay. Oops. There we go. Okay, so let's try this again, shall we? Okay. So 246 sine 0.17 x minus 1.57 plus 295. Okay, A, B, C, D. So again, right here, this is what the equation has to look like. You're going to put numbers in for A, B, C, and D. Okay, and it's just a drag and drop. Okay, so the rest of this now is interpretation questions, just like we did in the polynomials unit. So I'm going to leave this question here till the end. We'll come back to it though. Okay. So then what we want to do on our calculator, so go back to your calculator. So what we want to do now is we want to plug this exact equation into y1, not the rounded values, the exact one. So go to y equals, remember, twinkle, twinkle, little star. So vars 5 over, enter, twinkle, twinkle, little star. Okay? Hit graph, and we should see connect the dots. Looky there. She's a beaut. Okay? So vars 5 over, enter. Okay. Now, for part C, you do not need the graph for part C. Look at the table, look at the context. For part C, it says, what is the maximum and minimum heights? So what's the highest this person went? So this is the maximum. What's the lowest this person went? 49. So that's the minimum. Now, here's the issue. This is called regression. Now, we just so happen this table gave us a perfect sine wave. Okay? But you remember when we were doing cubics or quadratics and sometimes the points didn't quite line up and it kind of approximately went through it? In that case, then you couldn't read off of the table. What'd you need? Is it not working? Go to your Y1. Oh. Oh. No, what she's got is she haven't done your window settings. Oh, yeah, you did. Yeah. Oh. You have to be in radian mode. Oh. Okay, everything has to be in radian mode in the course. There you go. Okay, so when you get your, yeah. So when you guys clear your when we clear your calculators for the diploma, they'll automatically be put in radian mode, and you're going to keep them there. You're not going to muck with it. Okay. Okay. So I just want to go through. If you didn't see these on the table, I just want to review the button pushing with you because you may or may not. You may or may not think to look at the table. So if I want to find the point of this maximum right here, okay, go to trace. To find the maximum, you pick number 4 for maximum, right? Straightforward. Okay, what were your window settings for X? What were your window settings for X? We went from 0, like 0 to 100. So I'm trying to find this guy right here. So give me a number on the left side of it. 1. Fantastic. Now, when you give me a number on the right side, it can only be over here. It can't be past this. So I'm looking like this is about at 20-ish. So maybe pick like 30. Let's see what happens. Yep. So it's just on. So if you pick wrong, you just start again, right? You pick 1 and maybe 27 or whatever, right? Hit graph, hit enter to get past the most useless feature ever. And there it is. 541 is the maximum. And that they reached it at 18.5 minutes. Now, that is different. Sorry, and that's exactly what's on the table. The table shows 18.5 minutes, 541 height. So it's exactly what was on here. Okay. How long does it take to make one complete revolution? Okay. So you get on right here. You're going to go up. You're going to come back down. We need to find the time. So is time the x value or the y value? Is time the x or the y? X. So we need to find the x value of this point. Now this point is a minimum, right? It's at the bottom of my curve. So second trace, this time pick number 3 for minimum. Okay, so I'm looking for this guy right here. So give me a number on the left. Okay, and then give me a number on the right. 45. Okay, hit enter. So how long does it take to go all the way around? 37 minutes. Now again, that is on your chart. If you look on your chart, they start at 49 feet. Look there, they get to 49 feet after 37 minutes. So you could have found all these answers off the chart. I'm just reviewing the button pushing on the calculator because that's what we're doing today. Okay. Part E. If Jordy wanted to wave at Yale when they were directly across from each other, what times would Jordy tell him to be at the window of the building? Okay, so right here in this question, right here, we've got this little paragraph. So it says Jordy got on the Singapore Flyer at noon. So what that means is that he got on here, so this point right here is at noon. Okay, we just determined it's 37 minutes. So 12:37 p.m. he's gone all the way around, right? We just discovered that. His friend Yale was in a building directly across from the Singapore Flyer at a height of 400 feet off the ground. So this is a height, or in other words, it is a y value. So we've got a y value of 400. When was Jordy level with Yale? Okay, how do I do this on the calculator? Yep, right. Okay, so what that's going to happen is we're going to have a straight line now for Yale. And we want to find out this number and this number. So when he goes up, he'll see him. And when he comes back down, he'll see him. So we just want to do it for one cycle. We don't need to worry about all the others. Okay? So it's where they cross each other. Which word here means cross? 5. Now, move this cursor so it's kind of close to this very first point. So just use the arrows to shimmy it over. That's fine. It depends on where you put it. It doesn't matter if it moves on the red line or the blue line. Okay, so you don't want to put it bang on. You just look. As long as the cursor is closer to the point that you're looking for than it is to any other point, you're good. Yes. Hit enter 3 times. So at 12:12, so 11.8 minutes after, right? So 11.8 minutes after he starts the ride, he'll see Yale. Okay. So second trace, number 5. Now move the cursor to the next point. So to this one. Whoop. To right there. Now hit enter 3 times. Okay. So at 25 minutes after he starts the ride. So at 12 minutes after the ride and 25 minutes after the ride, or in other words, at 12:12 and at 12:25, he can wave to Yale. Okay. Yes, because it said, I think it says at the, so on the diploma, it will say, what is the first time after climbing on the ride will Jordy see Yale? And that would be this one, 11.18, right? Or it will say how long, so it will say Jordy goes once around, just once around. At what times will he see Yale? Okay. Add on a part F. Okay. Add on a part F. And 25.2 or 25 minutes and 12 minutes. Yeah. So at 12 minutes after he starts on the ride and 25 minutes after he starts on the ride. Okay, part F, I want you to write this. Okay. What is his height 30 minutes into the ride? Yes. Yep. So what is his height 30 minutes into the ride? So if we look at our little chart, so 30 minutes is right about here. So what I've done is I've given you an X value, and this time you're looking for a Y. So which one do we pick for this? Number 1. And you go to where X is 30. Sorry, I should have erased Y2. I just didn't do it. And you get it right here. How tall is he off the ground? 203 feet off the ground. Okay. So what you should do, what I should have done is I should have cleared out. Okay. You clear out the other Y. Okay. And then we pick number 1. We go 30 minutes and 203 feet off the ground. Yes. 200, right. So you can only have one line there. Otherwise, it'll look to the wrong thing. Okay, so take your break. When you come back, we'll do one more example, and then we'll call her good for the unit. We're done. We're done. Like, finito. Holy moly. And these two are pretty straightforward. It's nothing too major here. So the key with using your calculator to solve stuff, and it seems pretty minor, but the key is the window settings. So the window settings will allow the calculator to draw the picture where you need it drawn. Now, can you do a random guess and check? Yes. But what you want to be able to do is you want to be able, the window, you want to be able to see the top and bottom of the wave and the start and finish of it for one full pattern. That's what your goal is. Now, if you read the question, you should have some frame of reference for that scenario. Okay? So it says the depth of water in a harbor, T hours after midnight, can be approximated by the sinusoidal function, blah, okay? Where T is 0 to 24. So T, remember, is your time. So what this means, if I draw a little picture here, so T for time, this is going from 0 to 24 hours. So what this is 24 hours after midnight, or in other words, one full day of time, right? It's 24 hours in a day. So if you understand this right here, then you now automatically know your X min and your X max because you want to go for 24 hours. I used the example at the start of class on the amount of sunlight we get during a year, right? So on June 21st, you get 16 hours. December 21st, you get 8 hours. The next June 21st, you get 16 hours, right? It goes this pattern. If I'm using days of the year, how many days are in a year? 365. So you would go X min 0, X max 365. So you could see an entire year's worth of days. So if you understand the context of the question, the settings are actually pretty simple. So if this is talking about time in a day, there's 24 hours in a day. So 0 to 24. Okay? Okay, it's the Y that's a little trickier. Okay, so the way this was written is kind of the way Math 30-1 is written. Math 30-2, what they will do is they'll put this plus 12 on the end, like that. Okay. So we know that that plus 12, This is the midline. And we know that the 5 is the amplitude. So it's going to go up 5 and down 5. So our maximum, our amplitude, the amplitude is 5. The midline is y equals 12. And we can tell that from looking at the question. Now, if you couldn't see that, could you just guess and check y mins and y maxes till you get it to work? Yes. Okay. Okay, period. The formula for period is 2 pi over b. So in your little formula here that you were given, this right here, that is the b value, 0.524. So you're going to go 2 pi divided by 0.524. And you're just going to punch that thing in. And you're going to hit the pi key. Okay? Because right now, this number, that doesn't mean anything to us, right? Because remember, the period is the length of one cycle or one pattern. What do you get out, Melissa? 11 point. So let's say 12. Hours. Oh, nearest tenth? Yeah, so 12.0. Right? Now, does that make sense? Even if you know nothing about tides, you should know that it goes in and comes out every 12 hours because the moon pulls the gravity of the tide. So if you go 2 pi divided by that b value, you should get out a number that makes sense based on that question. Okay. So window settings. So for x, I would go from 0 to 24. And for the y's, I would go from 0 to 20. Okay. So again, if we give you the equation, you want to be able to find the a value, the b value, and the d value, because that will tell you your window settings so that you can go from there with it. Okay, now if you can't figure it out, plug it into your calculator and start guessing and checking until you get the nice little waves to appear. Okay, so let's plug this thing in. So 5 sine, so I'm just going to clear this out. Now, I'm not using regression, so what do I have to do? When you're not using regression, you have to go up to plot 1 and unbold it. Okay? So 5 sine 0.524 x, and then finish off that bracket and then go plus 12 on the end. The what? Oh, sorry, I didn't even see it there. 0.1571. Sorry, I didn't see that. Yes, enter it in exactly the way it is in the question. No. So I just moved it so it looked like A, B, C, D, like what we've been playing with. So, but you can plug it in any way that you like. Okay. Now, go in and change your windows. So we know we want to go from 0 to 24, and we want to go from 0 to 20. Now, fingers crossed, you get a wave to appear. There you are. So the tide goes out, comes, so right here, this point, that's what we would call high tide, low tide. High tide, low tide, high tide. Straightforward? Okay. Okay, so if we look at question D, use the graph of the function to determine to the nearest tenth of a meter the depth of the water at 2 p.m. Okay. You need to know how to tell time. So the question says, if you go back up to the original question, it says T hours after midnight. So what that means, okay, what that means, so this is your height, this is your time, this right here is midnight. That's your starting point. So how many hours after midnight is 2 p.m.? Okay, so noon would be right here. 2 p.m. would be right about here. So how many hours after midnight is 2 p.m.? It's 14 hours after midnight. Okay, I don't think the diploma will make you figure that out. I think they will tell you 14 hours after, they'll say 2 p.m. and then brackets 14 hours after midnight, because they can't assume that you guys know how to read an analog clock, which is sad. But an analog clock, okay? Right. Like for that, like they can't assume that you guys know what 20 to 12 means. Yeah. In our society, understandable. But if you're coming in from a war-torn country and you've never seen an analog clock, you wouldn't have a clue what we're talking about. No. It's actually shocking how many kids can't tell time on something like that. Like shocking. So, anywho. Okay, yes. Now, 14 hours. So we're looking for the depth of the water to the nearest meter. So is 14 hours an X value or a Y value? 14 hours is X. We're looking for Y. So how do we do that in the calculator? Nope. We go number, press 1. 14 hours for X. So how deep is that water? 14.5 meters deep. Okay. That's the hardest part of this. So I shouldn't say that. Window settings are problem number 1. Problem number 2 is deciding if you should be using number 1 or number 2. Should you be looking for an X value or are you looking for a Y value? Get that straight in your head. You'll be golden. So 14.5. Okay. All right. It says a ship requires a minimum of 8.5 meters of water in the harbor at midnight. By what time to the nearest necessary 10 minutes? So we're going to ignore this. Okay. We'll say nearest 10th. Must it leave to prevent grounding? Now, on the diploma, they will tell you what grounding means. Grounding means is when the water is too low for the boat to stay floating. And what it literally does is it hits the ground, hits the base of the ocean. Okay? So grounding is when think of it as high centered. Same idea. Okay? So this 8.5 meters is a depth. Or in other words, it's a Y value. We're looking for X. So into Y2, you're going to plug in 8.5. Or whichever one you want to do. Okay. So here's our picture. So this right here, this is midnight. Okay? We need to know this point right here. Just the first one. Because it's in the harbor right now, right? It came into the harbor. It's sitting in the harbor. The water level is going down. At what time does it need to get out of there so it doesn't ground? So intersect. And we just want to find the first intersection. So I'm just going to scroll over to it. This is the worst part. Okay. Hit enter 3 times. So it's got to be out of there 4.5 hours after midnight. So about 4:30 a.m., give or take. Okay. So 4.5 hours. Okay. Now what's the next question? What is the next time to the nearest 10th that the ship can safely come back? So the water level is too low all in here, right? It would ground. This is the next time that it could come back. So we want to find the next intersection point. What you get? So 7.5 hours after midnight. So about 7:30 a.m. it can come back in. So it has to leave by 4:30 a.m. It can come back 7:30 a.m. Interpretation questions. Now your diploma is full of context. That's what they like to do. It's scary at first because of the reading, but in many ways it's good because the answer should make sense, right? On this question, a negative answer, nuh-uh, right? Makes no sense at all. Okay, we're going to do one more question together. And it's the very first one actually, so go all the way back to the first page. And it's page 391. Okay, so these ones are actually a fair bit of reading, but just read a sentence, put the number on the picture. Read the next sentence, put that number on the picture, and just keep going. So it says a nail is caught in the tread of a tire. So this is the nail right here. And the tire is going around in a circle. So that nail, it goes up, it comes down. So as that wheel rotates, right? So as this wheel goes round, right? Like that, the height of the nail goes up, down, like that. Make sense? Okay. So A and C are maximums and minimums, and B and D lie on the midline. So we know that this is the midline, this is the top, this is the bottom. So let's put some numbers onto this thing. Okay, so it says Jack and Gills, I don't know, I'm going to call them Jill. Jack and Jill will give them the following information to determine the height of the nail after 6.5 seconds. So that's what we're looking for. How high is this thing at 6.5 seconds? The tire has a diameter of 50 centimeters. What does diameter mean? Nope. Total distance across. Okay? So total distance across is 50 centimeters. So that tells us that the bottom is at 0, the top is at 50. That one sentence tells us the minimum and the maximum. What does it also then give us? Which is going to be what? No. Half. So 25. Right? Half of 50 is 25. So if I go 25 this way and 25 that way, there's my midline. So that one sentence right here gave us the maximum, the minimum, the midline, and the amplitude. A whole thing in one sentence. Doesn't take much. The tire rotates at 10 revolutions per minute. Okay? So look at your units. Time in seconds. How many seconds in a minute? 60. So instead of thinking of it in terms of per minute, think of it in terms of seconds. So this thing goes round 10 times every 60 seconds. So then how long would it take to go once around? If it goes 10 times in 60, it would go one time in 6. You just divide everything by 10. So that means, so right here, it's going to go up, down, and come back by the time you get to 6 seconds. So there's an interpretation piece here. Now, if you didn't understand that, the next 2 sentences will fill that information in for you. So it says after 1.5 seconds, it reaches its maximum point. So right here, is 1.5 seconds. So you should be able, we've talked about this. If from here to here is 1.5, what is it going to be from here to here? So that puts it at 3. What's it going to be from here to here? What's it going to be from here to here? So even if you didn't get the 10 revolutions in that, you could use that 1.5 idea. Does that make sense? So either way, you should be able to get that scale. Okay, so this right here, it's 3, this is 4.5. And the 4.5 was told to you there as well. So again, you could figure it out. Okay, so the question is, determine the equation. So we'll just do this part right here. Okay, so we've got our height. What's the amplitude? 25. What's the midline? 25. Okay, so to find B, 2 pi over period. Period is the length of one complete cycle. How long was one complete cycle? 6. So notice the question says exact values. So on your calculator, 2 over 6 reduces down to 1 over 3, and then you just stick the pi back in. Okay. Okay, let's plug this thing into our calculator and then we're done. So 25 sine 1/3 pi t. Okay, so y equals, okay, so 25 sine 1 pi divided by 3 plus 25. And make sure you finish off that bracket. Yes, I need an x. Okay, thank you. Now, if it hadn't occurred to me, if you leave off the x, you always just get a flat line. So then you know you've done something wrong. Okay, window settings. We know we need to go only for 6 seconds. So I'm just going to go for 10, just so it's rounded up. And we know we need to go up to 50, right, for the height of our tire. There we go. That nail's going around. So the question says, how far, this is part D, how far to the nearest 0.1 centimeters is the nail above the ground after 6.5 seconds? So 6.5 seconds, is that an x value or a y value? X, it's a time, right? Because time is here. So pick number 1, 6.5 seconds. So it's 37.5 meters off of the ground. Or feet or whatever units we're using here. Oh, centimeters. 37.5 centimeters off the ground. Yeah, it's not meters. I'm an idiot. Okay. Okay. I am tired. Okay, so in terms of the assignments, that's it. We're done the course. Okay. Okay. So here's the assignment. Okay.